Okay, so the work from the lesson here that you might have missed is called the remainder factor theorem. And from the last lesson, okay, we had here a cubic, okay, and we were able to factorize it, okay, and we will get, in this case, 3 brackets, okay, we'll get 3 brackets at most, okay, you can't get more than 3 brackets, but we can say each of these now are factors. As it says here, the factors of this are x minus 4, x minus 1, and x plus 1. Now, if they are factors, okay, that means that they divide into it perfectly without leaving a remainder. And it's just like numbers, for instance. If you think about 24, factors of 24 are 1 and 24, 2 and 12, 3 and 8. Let's consider 3 and 8, for instance. They are factors. And, of course, we can write 3 and 8. We can write 24 as a product of 3 and 8 here. Okay, because 3 divides into 24 and 8 divides into 24 perfectly, okay, without leaving a remainder. And it's exactly the same as what we've got here. We've got this algebraic expression here written as a product of these linear factors here. Okay, it's no different to when we do number work here. These are factors. 3 is a factor of 24, so is 8 a factor of 24. So it divides into it perfectly without leaving a remainder. And we can say the same about these. X minus 4, you can divide into that with leaving 0 remainder, and the same for that and for that. So what we're going to do now is we're going to consider a general case, right? So in general, if we consider a polynomial, and we can call it a function of x, right? So this is an example of a polynomial, okay, where the highest power is 3, okay? But we can call it f of x. I can say f of x equals to this. F of x just means function of x, right? So it's a function here. You do something with x. You do all this. So in general, consider a polynomial f of x with a factor of x minus a, okay? So we don't need that by there. Mistake there by me. So it's got a factor of x minus a, okay? So a would be a number, for instance. Just like we've got here, right? We've got x minus 4 as a factor. So 4 would be the number. Then it says, when we work out the value of f of a, we will get 0. So, essentially, this is the remainder theorem here, okay? If we've got f of x, and it's got a factor of x minus a, where a is a number, then when we work out the value of f of a, we will get 0, okay? In other words, if f of a is 0, then x minus a is a factor of f of x. However, if we've got another linear term, right, and f of a is not equal to 0, okay, it comes to something else, then it's not a factor. It doesn't divide into it perfectly, because we have this here, which would be the remainder. So if it's not 0, it'd be something else. So that's why we've got here the value of f of a is the remainder when f of x is divided by x minus a. So when we divide f of x by x minus a, the remainder is given by f of a. So let's just try it for a couple of these up here. So we know x minus 4 is a factor of this. So if I call f of x, first of all, if I call it f of x, okay, right, well, x minus 4. So if I correspond it to what we've got here, a would be 4, wouldn't it? Because the minus is already in place, so a would be 4. So I'm literally going to work out f of 4, okay? So if I put 4 into here, okay, and work this out on my calculator, it literally comes out as 0. So because it comes out as 0, the remainder is 0, which means x minus 4 divides into this perfectly. And we'd expect that, wouldn't we? Because it's one of the factors. Let's try x minus 1. So let's put 1 in there, okay? Because again, x minus 1, if I write it underneath here, x minus 1 is a factor. Well, that means a would equal 1, wouldn't it? So f of 1. So 1 cubed minus 4 times 1 squared minus 1 plus 4. Work that out, it comes out to be 0. Okay? So it leaves a remainder of 0. Put another one in. Well, what's the other one? X plus 1. Now, got to be careful here. I'll write it up here. Okay? If this is the general term here, x minus a. Okay? So if I've got x plus 1, think about what a is going to be in this case. I need to rewrite this so that I've got like a minus here, so I could rewrite this as x minus, okay? So then a would have to be minus 1, wouldn't it? If that makes sense. Put it in a little bracket if you want. A would have to be minus 1, okay? Because I've got a plus here. And the minus is what we've got as part of the generalization. And then if a is minus 1, that would then represent that, okay? So I'm going to put minus 1 in. So if I put minus 1 all cubed in, minus 4 times minus 1 all squared, minus x, so there'll be minus 1, plus 4, it comes out to be 0 again, okay? Put any other value in, it won't be 0, because that would represent something that is not a factor. Okay, so we're going to learn about this by example, so don't worry if you didn't quite get that. It's worth watching the video again, watch it a couple of times, right, till it sinks in, hopefully, and then look at the examples, and the examples will really help.